Wireless. It is such the rage in networking today that we are going to be giving you 2 live lessons on this particular subject. We, in this live lesson, will break down for you everything that's most important to know about the configuration of wireless local area networks. So we'll talk about things like the wireless technologies that we can use and key ingredients that we're going to need to master in order to effectively set up a wireless network infrastructure. In a subsequent live lesson, we'll be looking separately at the hugely important topic of securing these wireless cells. The minute even the layperson experiences wireless, they think to themselves, boy, is this secure? And that'll be the subject of the follow-up live lesson to this one. So I hope you'll join me in this live lesson as we look at the configuration initially of the wireless network infrastructure. What is one of the most popular technologies today? Wireless networking. That's right, to go ahead and take that physical layer and not have it be made up of cables, but instead have it be made up of radio frequencies. We love being able to get our network data anywhere we want over the air thanks to wireless technologies. Keep in mind that when we speak about wireless, we might be speaking about mobile wireless connectivity. So we might be talking about accessing data on a cell phone, for instance, a smartphone, I guess as we should call it these days. Or we might be talking about wireless local area networking. This is so cool, where you have an area of your network where the wireless radio frequencies have replaced all the cables. And these folks that are using the wireless equipment, they can easily get to the information that's on the wired LAN because these 2 technologies are bridged together. And notice that's another option for overall wireless technologies, the bridged Wi-Fi environment. Bridging is typically done in like a large city where you have an antenna on one building sending a signal over to an antenna on another building, and we have bridge devices at each location which are going to literally take that data as it's beamed from building to building and send it down into the local area network infrastructure in the buildings. So pretty cool. Now, wireless LANs are certainly what most of us network engineers think of these days when we hear wireless. Notice that wireless LANs have replaced the wired technology at layer 1 and layer 2, and the upper layer protocols don't care, don't know. It's very similar to legacy Ethernet. It's going to use MAC addresses, and there's one issue here with the way in which wireless LANs work today. You know they're not as fast, but the question is, why aren't they as fast? Well, because they're using a shared media. Yeah, think of an old-fashioned hub. Collisions are possible in the wireless local area network, so this is going to impact our speed. There's a trade-off, right? Sure, we don't have to have the wires laying all across the floor, but sure enough, the communications are not as efficient with wireless local area networking. In wireless LANs, we use an older style technology called Carrier Sense Multiple Access Collision Avoidance. Specifically, wireless LANs use something called DCF, Distributed Coordinated Function, with a series of random backoff timers to avoid collisions. What'll actually happen here, folks, is a collision will happen. The technology will detect that and resend after waiting a random amount of time. Ew, yuck. This is much less efficient than collision detection technologies that we have in our modern Ethernet. But, as I said, we just have to face the facts that there is a trade-off here with wireless technologies, and that is the inability to detect collisions. Now, when you configure a wireless LAN, you know that you configure a service set identifier, or SSID value. Now, it is true that devices that don't have a matching SSID will ignore each other's traffic, but keep in mind that there are still collisions possible between your different SSIDs. When you fire up your machine and you go to configure your local device, your local access point, you're going to find no matter what access point you're using, a similar set of configuration parameters, because all of this is standards based. So you can see, once I put in my correct password, let's try this again. So you can see here that I am on a Verizon wireless network environment. And if we go over to the wireless option, you can see, sure enough, I have to input the SSID for my particular network. So we're going to have a field for SSID in every single wireless setup. This is all part of the standards. By the way, here I'm just looking at status information, but if I go over to the main button, that's not where I want to go. Where do we want to go here? Basic security settings, for instance. Here you can see I turn on the wireless, I set up my SSID, and then I go ahead and select a channel or allow it to be selected automatically. And then we configure the form of wireless security we're going to be using, and we enter in our key information. So the great news is when we're configuring our wireless networking equipment, while there could be many different style screens for the different vendors, we are going to be inputting this same type of information, the SSID, the particular security we're going to use, the channel that we're going to be on, etc. Now, if you don't want to use an access point, you can avoid one and just send wireless data across the air between two systems without a wireless point. And when you do this, this is called an independent basic service set. Most of us operate in the basic service set infrastructure mode, where we do have an access point in our home, for example, and it's providing that SSID out to all the devices in the home. But one really cool thing to keep in mind is infrastructure mode, which you can engage in. With infrastructure mode, you have the ability to extend, or the extended service set infrastructure mode, excuse me. With this variation, you have the ability to extend the reach of the wireless local area networking. What you do is three things, and I certainly would know these three things if I were you. In step one, you add an access point using the same SSID, okay? In step two, you make sure this SSID AP is on a non-overlapping channel. So you're going to pick non-overlapping channel numbers. And in the third step, you're going to make sure there's at least a 30% overlap in the two cells. So that's how you create the extended service set to expand your popular wireless local area network. Remember our three things. Add an AP with the same SSID, make sure there's that 30% overlap, and make sure that, non-overlapping channel. I better run through them again. So, add an AP with the same SSID, pick a non-overlapping channel, and then make sure you get at least a 30% overlap in the cell signals. What an exciting way to expand your wireless local area networking. By the way, when a client comes up, it will probe the local access point, and access points can also send out unsolicited beacons so they can be found more easily. And then the client will start its association, and the access point will either accept or reject that association and then install the client's MAC in its system. We know that 802.11 is going to utilize is going to define for us our wireless standards. And if you look at 802.11a, for instance, or no, this is B, excuse me. If you look at 802.11b, it's going to use the 2.4 gigahertz range, and it's going to have channels 1 through 11, with non-overlapping channels being 1, 6, and 11. So this would certainly come into play if you wanted to extend your service area. Notice 802.11b. Oh, you know what? This 802.11 was the initial standard. Yeah, that was the initial standard. Then 802.11b came along, and 802.11b allowed us to expand data rates up to a theoretical of 11 megabits per second. So some new encoding was used, differentiated quadrature phase shifting was used in order to ratchet up the speeds to 11 megabits per second. 802.11g added 8 more data rates to 802.11b, allowing us to go up to 54 megabits per second. Finally, 802.11a, which really never caught on big here in the United States, allowed 54 megabits per second using the 5 gigahertz channels and 12 to 23 non-overlapping channels. But we know the most exciting way to implement your wireless technology today is to utilize 802.11n. 802.11n cleverly utilizes both the 2.4 and 5 gigahertz bands. It uses orthogonal frequency division multiplexing in its operation, but what we really care about is its speed increases. Thanks to 802.11n, if we're in a pure N environment, N clients and access points, we could theoretically reach 300 megabits per second. One of the reasons this is, by the way, is they use something called MIMO, multiple input, multiple output antennaing with this 802.11n technology in order to speed it up. So folks, that was a look at not only the specific 802.11 technologies that we can take advantage today, but also a look at the various options we have when it comes to wireless networking. Whether we're setting up a wireless LAN in a simple, basic service set type of configuration, or we're doing one of those fancy extended service sets.